Hi, I'm Dr. Chad Larson. Thanks for joining me in another episode of Keep It Real. So today we're doing the third of a three-part series on dopamine. So dopamine is a neurotransmitter, it has lots of other jobs in the body, but the focus of this three-part series is really on dopamine's effect in the brain as a neurotransmitter. And in part one, we talked about how dopamine has really evolved over time. And just as importantly, our understanding of dopamine has evolved over time. So back in the 1950s, we had a very different understanding of what dopamine does in the body compared to today. So you can go back to that episode and kind of understand the history and the evolution of dopamine. And then in part two, we talked about really the importance of dopamine. Why do we have to care about dopamine as a neurotransmitter? And what are some of the symptoms that evolve in the body and manifest in the body if dopamine utilization is a problem in the body, or there's a deficiency of dopamine in the brain, then what kind of symptoms oftentimes manifest. So check out that episode to learn more about dopamine deficiency symptoms. And then today we're going to talk a little bit about if some of those symptoms seem to be true for you. There's some things that you might want to think about to talk to your doctor, or things that you can start applying in your life to help to improve your dopamine utilization, and maybe to even increase dopamine if it's deficient in your system for some of the reasons that we'll talk about. So this is kind of a crazy picture here. I'm going to break that down for you in just a moment, and kind of talk about why those things are there and how they really influence the production of dopamine in the body. But first, I thought I'd just mention a little bit about how dopamine is produced in the body. So dopamine first starts out as an amino acid called phenylalanine. Phenylalanine. Phenylalanine is an essential amino acid. When you hear the word essential with an amino acid or a nutrient, what that means is that the body doesn't make it. So we have to get it from an outside source, like food, ideally, or even certain supplements. So phenylalanine is an essential amino acid that we don't make, and we have to get it from an outside source like food. And then phenylalanine is converted into an amino acid called L-tyrosine. L-tyrosine is considered a non-essential amino acid because it's made from phenylalanine. Tyrosine we can also get from foods, but the body also makes it, so that's why it's considered a non-essential amino acid. So when you hear non-essential, don't think that it's not important. Non-essential in medical or scientific terms means that the body makes it. So you just have to get the building block to make tyrosine at the very least. But there's a lot of foods, like I said, that also have L-tyrosine in it. So L-tyrosine gets made from phenylalanine with a certain enzyme, and that enzyme is called phenylalanine hydroxylase. So let's just put pH, phenylalanine hydroxylase. And pretty much every enzyme that converts, from one biochemical to another biochemical requires certain cofactors. And a cofactor is usually a nutrient that makes that particular enzyme work properly. And the cofactor for phenylalanine hydroxylase, there's actually two of them. It's iron. Let's put that in blue. Iron. And BH4. BH4 is an abbreviation for tetrahydrobiopterin. Tetrahydrobiopterin. And iron. So you can see if somebody's just a little bit iron deficient, like we see in people who have anemia, or even there's kind of subclinical levels of anemia where they're not fully deficient in iron, but they don't have quite enough of it. This can be determined by basic blood work, that if a person is low on iron, then that's going to affect the ability for that enzyme to be developed, and that's going to not allow phenylalanine to be produced into tyrosine. We're going to get that a little bit more when we talk about some therapeutic considerations. And then L-tyrosine has to get converted into L-dopa. L-dopa is a precursor to dopamine. And so these all have cofactors as well. L-tyrosine has to get converted to L-DOPA with an enzyme called tyrosine hydroxylase. And that actually requires the same cofactors. But to go from go from L-DOPA to dopamine requires a different enzyme, and that enzyme is called an aromatic amino acid dehydroxylase. So, aromatic amino acid dehydroxylase, and that one requires a little bit different cofactor. That requires P5P, pyridoxal 5-phosphate. That's vitamin B6. So let's just go back up here for a second. This whole section here, let's use black. This happens in the liver. Phenylalanine is converted to tyrosine in the liver. And then once tyrosine is produced, then tyrosine flows throughout the bloodstream and goes up to the brain. And it crosses the brain, it kind of has to jump on a taxi cab. The taxi cab is called large neutral amino acid transporter. And that large neutral amino acid transporter moves tyrosine up to the brain, and that's where it gets converted into dopamine. So this is brain. And this is large neutral amino acid transporter. And so this is made in the liver, that's made in the brain, and the dopamine gets further broken down into metabolites. Let's start over. Metabolites. Let's just say met. And norepinephrine into epinephrine. We can talk for a whole hour just on norepinephrine and epinephrine, but for today's purposes, we're just going to talk about dopamine, and this is kind of the production of dopamine. That phenylalanine gets converted to tyrosine in the liver via this enzyme with some iron and some BH4. But what we have to know about BH4 is when BH4 is used up, it gets kind of recirculated from its metabolites called BH2 and BH3, and that gets recirculated back into BH4. And that recirculation requires vitamin C, and it requires P5P, that pyridoxal 5-phosphate, which is B6. So we need iron, vitamin C, vitamin B6 to make tetrahydrobiopterin, and then this is the way that the body makes ultimately dopamine. So with that in mind, let me just take a sec and cruise through this section here, which is really where we can start to utilize different dietary and lifestyle factors to help influence our production of dopamine in the brain. So let's just start with the stuff in blue first. The stuff in blue is really directly influences our utilization and our production of dopamine. So let's start there. So low carb diet. Why is a low carb diet helpful? Because when we are on a high carb diet causes more glucose to go up, causes more insulin to go up, and increases the chance of insulin resistance. When a person is in insulin resistance, that's going to accelerate the rate at which dopamine is broken down into its metabolites. And so that's going to ultimately decrease your production of dopamine. That's why a lower carb diet is better for that. No aspartame. Aspartame is a sweetener that you'll find all over the place in all kinds of products, from gum and soft drinks. It's all over the place. And all you have to do is read the label, and on the label it'll say aspartame. It's also NutraSweet, so you might see it as that, or Equal. Those are like little packets of aspartame that you can put in things to make them sweet. But aspartame is a pretty nasty molecule, and it definitely messes with our production of dopamine. And here's the reason why. Is just look on a package that says aspartame, and in big, bold letters, it's going to say phenylketonureas. And a phenylketonureas is a person who has been diagnosed with PKU, or phenylketonuria. And phenylketonuria is a genetic problem where they can't make phenylalanine hydroxylase. So this person, or these people with PKU who can't make phenylalanine hydroxylase, they can't convert phenylalanine into tyrosine. So they put a warning on this package with aspartame because aspartame breaks down into 50% phenylalanine. So if your body has too much phenylalanine and you have that condition called PKU, then it causes phenylalanine gets to the brain and causes really severe brain damage. So they have to put a warning on all packages with phenylalanine or with aspartame to say that there's a lot of phenylalanine in this product. But really the warning should not just be for people with PKU, it should be for everybody. Because anytime we have an excessive amount of phenylalanine, then that's going to actually monkey up the whole works here. And the reason why, you go, okay, well, phenylalanine is a precursor to dopamine. Why wouldn't that help with dopamine production? Here's the reason why. If you get a flood of phenylalanine to the system, phenylalanine also jumps on the same taxi cab as tyrosine to get into the brain. So if you take something with a whole bunch of aspartame in it, that's going to cause a flood of phenylalanine into your body. And then phenylalanine is going to take all the taxi cabs, and there's not going to be enough of this transporter to take tyrosine across the blood-brain barrier into the brain. So they compete. And so if you have too much phenylalanine, which is going to happen if you have aspartame, then that's going to affect your body's ability to make dopamine. Because phenylalanine is not converted to tyrosine in the brain, only in the liver. So once phenylalanine gets into the brain, it's going to take priority with this transporter over tyrosine. So the net effect is going to be actually a deficiency of dopamine. So no aspartame. Also dysbiosis. Dysbiosis we can talk a long time about, but just suffice to say that dysbiosis is when there's an imbalance of the good and bad bacteria in your gut, and that can cause things like leaky gut and inflammation. And when there's inflammation problems in the gastrointestinal tract, it's going to affect our ability to absorb certain nutrients that we need to make dopamine. Then we have balanced hormones. So hormones are very vital in the part of the brain. The part of the brain that makes dopamine is called the basal ganglia. And more specifically, it's called the substantia nigra and the ventral tegmental area. Those are the two key areas of the brain where dopamine is made. And we know that hormones, or let's say a deficiency of certain hormones, for men, testosterone, if there's a testosterone deficiency, that could affect very clearly the ability for your brain to make dopamine. With women, it could be progesterone or estrogen, but either of those hormones, probably progesterone more often, if that's deficient, that could affect our ability to make dopamine. Then we have boost antioxidants. That area of the brain called the ventral tegmental area, where dopamine is made, is actually very vulnerable to oxidation. Oxidation or oxidative damage is a very inflammatory process in the brain. If that inflammatory process gets out of control, it starts to destroy the neurons that are making dopamine. So the net effect is going to be you're not able to produce enough dopamine. So certain antioxidants, we know that glutathione, you can actually get glutathione in certain liposomal oral delivery systems. It's kind of hard to find, but if you talk to your doctor, if you talk to the right kind of doctor, you can get a supplement like that. And in our office, sometimes we do intravenous glutathione. You can't really take glutathione as like a pill. It just doesn't get absorbed. But there's other precursor nutrients like NAC, or N-acetylcysteine. N-acetylcysteine helps to boost glutathione levels in your body. So other antioxidants like blueberries and blueberry extract have a certain component in them called proanthocyanidin or anthocyanin, and these antioxidants really help to target that part of the brain. And other maybe botanicals. We'd put maybe in this area up here, botanical support like curcumin is a component of the spice turmeric, and that's been shown to have really fantastic anti-inflammatory and antioxidant properties on the brain. Fixed cofactor deficiency. Here's the cofactors over here. So you can see if you have a deficiency of vitamin C or B6 or pyridoxal 5-phosphate, iron, then that's going to affect your body's ability to make these downstream neurotransmitters like dopamine. So it's very important to have these evaluated by your doctor to make sure you're not deficient in these super important nutrients. Botanical support, we kind of talked about. Curcumin is really good in that regard. There's other botanicals that actually include some L-Dopa. There's a botanical called Mucuna. And Mucuna actually has dopa in it. So by increasing a person's L-Dopa, that can help to increase their dopamine. But you'd really want that to be supervised by a doctor before you just start taking a bunch of Mucuna, trying to boost up your dopamine. And frankly, it's going to be better for most people to make sure you're doing these other things in blue that we talked about first before you start taking something that has L-Dopa in it. And then the last one I have in blue is don't get addicted. And the reason why is because, as we talked about a little bit in part 1 and part 2, is that if we get addicted to a substance, alcohol, cocaine, gambling, there's a whole long list of things that we can get addicted to. It's like hyper function to the whole dopaminergic system in the brain. We kind of fry that pathway. So when we get addicted to something, it kind of just blows out that pathway. And if people come off of that drug, which obviously they should, it's going to cause a kind of rebound deficiency of dopamine. And then they got to do all these things to get back on track. So it's doable and it can happen, but it takes a lot of work and a lot of patience for that to happen. So to avoid all that, don't get addicted. So those are the things in blue. The things in the red are, once you have the cofactors, once you have things like good hormone balance, good gastrointestinal function, then the things in red are going to help your body utilize dopamine a little bit better. Kaizen. We've had past episodes on Kaizen. Just to put it briefly, it's a Japanese word that has a kind of a whole cool history behind it that you can go back and listen to that episode. But Kaizen basically means continuous improvement. You set a goal and you take little micro steps on your way to that goal. Like if your goal is to decrease carbohydrates, like refined carbohydrates in your diet, and you put 2 scoops of sugar in your coffee in the morning, maybe step number 1 is you go to 1 scoop of sugar in your morning, and that's it. And you do that for a few days, and then you move on to the next thing. Maybe you stop eating, the dessert after dinner or after lunch, and then you just take a really kind of stepwise steps towards your goals. And that little step that you make creates a little nice dopamine release in the brain, and that dopamine release in the brain helps you to take the next step forward to attaining that particular goal. Exercise. Exercise, we know, helps to boost neurotransmitters in the brain. Sunshine. And the thing about sunshine is vitamin D. We cannot make dopamine without vitamin D. I didn't put it here because it's technically not a cofactor, but it's important for that part of the brain to function properly. We need sunshine and we need vitamin D. If you're in an area or you have a deficiency of vitamin D, you can take a supplement with vitamin D. Get your vitamin D tested first so you know the proper dosage to help boost up your vitamin D levels. Meditation. Meditation, there's like a gazillion studies on how meditation affects our mood and behavior, and all that is because the neurotransmitters gets regulated amongst many other things. But meditation is really important. You got to have all these cofactors and other things in place that we talked about in blue. But if everything is in place, then meditation really helps to support our neurotransmitters like dopamine. Music kind of works similarly. Music is kind of relative to the individual, what kind of music seems to work for them. And then proper sleep. We just cannot support our neurotransmitters and our brain effectively without the proper amount of sleep. Even if you get all these other things right, if you're not getting a proper amount of sleep, the whole thing just kind of goes out the window. So that's how vital sleep is. Actually, everything that I have on here, remember, this came from a lecture that I did at a medical conference. Every single one of these that I have several studies that support the efficacy of what I'm saying for each of these. So there's some really interesting studies on sleep where they had certain subjects not sleep, and then other subjects had normal sleep, and then they evaluated their dopamine function, and sleep had a very significant effect on dopamine. Weight loss. Weight loss kind of goes with what we talked about here, low carb diet. We know that if you have insulin resistance, that's going to speed up your body's breakdown of dopamine. So the net effect is that you have a deficiency of dopamine. And cold showers. So again, there's some interesting studies on sort of cold therapy or cold treatment. You can do that just by taking a cold shower or a cold bath, and that helps to boost dopamine levels. But again, you got to have all these other things in place first so that dopamine is available. And then once it is, you can do a cold shower, a cold bath, and that really helps to boost your levels of dopamine and gives you all the cool things that we need for dopamine, which is proper movement and muscular patterns. We know that you need dopamine for normal muscular movement. And then we know it's good for kind of the psychosocial part of our brain. It's very important for just mental cognition. It's important for memory. And it's important in our decision-making process. So remember, kind of the most current understanding of the many things that dopamine does that we've learned just actually very recently is that dopamine is part of our cost to benefit ratio of making a decision. And once that decision is made, dopamine is going to give us the motivation to accomplish that particular decision. So let's say evolutionarily, we talked about this a little bit in part one, but just to kind of come full circle and wrap it up. If we have a goal as kind of a, as one of our ancestors, hunter-gatherer, we see that, there's a bunch of water buffalo that are grazing 15 miles away. We have to really take the cost to benefit ratio of that and say, is it worth it to go trek through this treacherous terrain to go hunt down one of these animals, kill it, which is very difficult, takes a lot of work, and then bring that food back and share it with our friends and family? We got little hits of dopamine along the way as we got closer and closer to that goal. That's all dopamine. Dopamine has really given us the motivation and the ability to make cost-benefit decisions that really allowed us to be as successful as we have as human beings. So pay attention to your dopamine. Check out the other episodes so you can learn about the background if this is the first one of the episodes that you listen to. And it'll give you kind of a pretty comprehensive understanding of the importance of dopamine, how to recognize if you have dopamine deficiency signs and symptoms, and then some ideas of what you can start to do to help balance your dopamine. So I hope that was helpful. And until next time, keep it real.